We are getting closer and closer to working with logarithms. But before we do that, we need to talk about one-to-one functions. First of all, if x sub 1 and x sub 2 are two different values in the domain, so x sub 1 and x sub 2, that's just to say these are two different x values, then f is a one-to-one function if the f of x sub 1 does not equal the f of x sub 2. So what does that mean in English? Well, first of all, it means our x values are different. And if the x values are different, then the y values have to be different. Think about functions that we had before. When we had a function, we said that every x value belonged to exactly one y value. But the y values could be the same. Now we're saying the y values cannot be the same if the x values are different. So our definition of a one-to-one function has two parts. Each x in the domain corresponds to exactly one y value in the range, and each y value in the range corresponds to exactly one x value in the domain. So an example of a one-to-one function then, -1, 3, 4, 2, 0, 7, 2, -5. So notice that this means that x does not repeat and y does not repeat. So look at the first relation. Decide if it's a function, and then decide if it is also a one-to-one function. Yes, it's a function. X does not repeat. Is it a one-to-one function? Yes, Y also does not repeat. What about the next one? Yes, it's a function. Is it a one-to-one function? No. All of these different x values have the same y value. It is not one-to-one. Is the next one a function? Yes. Is it a one-to-one function? Yes. What about the last one? Is it a function? Yes. Is it a one-to-one function? No. There's a y value that's repeating. What about when we look at a set of graphs? Let's look at the top three and first of all decide, are these functions? Well, we remember for a function we use which test? The vertical line test. So no matter where I draw a vertical line, for each of these, they intersect each graph exactly once. So these are all functions. Are they one-to-one functions? Well, if I look at this y value here, it has two x values. It's not a function. If I look at this y value, it has two x values. It's not a function. If I look at this y value, 1, this one, 1, 1, This is 1-to-1. Can you look at the last graphs here and decide whether or not they are 1-to-1 functions and functions? We know the first one here is a function. It's a cube function. Is it 1-to-1? Yes, it is. I know it looks like it's flat here, but it's not flat. If you plug in numbers, you'll know that about the cube function. The last one here, sure, it's a polynomial function. Yes, it is a function. Is it 1-to-1? It intersects the graph 3 times. No, it's not 1-to-1. I hope you noticed that each time I checked a graph, I was using a horizontal line. So we're using what's called the horizontal line test to determine if a graph represents a 1-to-1 function. The graph of a horizontal line intersects the graph of a 1-to-1 function exactly once. So when we were checking for a function, we used the vertical line test. When we're checking for a 1-to-1 function, we also need the horizontal line test. So one other property that's important about a 1-to-1 function is that the graph of a 1-to-1 function is always increasing or always decreasing. That means it doesn't change direction. If you look at the graphs of the two 1-to-1 functions here, I see that this one is always increasing. It doesn't change direction. This one is always increasing. It doesn't change direction. But when I look at this graph of the parabola, it's decreasing and then increasing. So my horizontal line intersects it more than once. The polynomial function here is increasing, decreasing, increasing. Every time it changes direction, my horizontal line intersects it more than once. So a 1-to-1 function graph is always increasing or always decreasing.